Welcome to this tutorial on calculating base-2 logarithms using NumPy. In this video, we'll explore the np.log2 function, which is essential for computing logarithms with base-2. This function is particularly useful in computer science, information theory, and algorithm analysis. np.log2 is a NumPy function that computes the base-2 logarithm of array elements. The mathematical relationship is straightforward. Log base-2 of x equals y means that 2 raised to the power of y equals x, for example. Log base-2 of 8 equals 3 because 2 to the power of 3 equals 8. The syntax for using np.log2 is simple. First, import NumPy as np, then call np.log2 with your input value x as the parameter. The result will be stored in your variable. The function accepts scalars, arrays, and even multi-dimensional arrays. Let's look at some basic examples. np.log2 of 8 returns 3.0 because 2 to the power of 3 equals 8. Similarly, np.log2 of 16 returns 4.0, and np.log2 of 32 returns 5.0. Notice that np.log2 of 1 returns 0.0, since 2 to the power of 0 equals 1. The real power of np.log2 comes when working with arrays. Create an array containing values 1, 2, 4, 8, and 16. When you pass this array to np.log2, it computes the base-2 logarithm for each element, returning an array with values 0, 1, 2, 3, and 4. Base-2 logarithms have several practical applications. They're commonly used for computing bit lengths and storage requirements in computer systems. In information theory, they're essential for entropy calculations and measuring information content. They're also useful in algorithm complexity analysis, particularly when analyzing divide and conquer algorithms. There are important edge cases to be aware of. The function returns not a number, or n for negative numbers, since logarithms of negative numbers are undefined in real mathematics. For 0 input, it returns negative infinity. Remember that np.log2 works element-wise on arrays, processing each element independently. Here's a practical example. Suppose you want to calculate how many bits are needed to represent certain values. Create an array with values 256, 512, and 1024. Apply np.log2 to get 8, 9, and 10, respectively. This tells you that you need 8 bits for 256, 9 bits for 512, and 10 bits for 1024.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.